Hello, guys. Welcome to CryptoCafe. I'm your host, Pedro Fubrocas, and today I'm joined with the usual suspects, Malman and Kiko. Nicholas will be joining us soon. And today we have a very, very special guest, Flat Earth Dave. Welcome, Dave. How are you doing, buddy?
Thanks. I'm always used to being introduced as a very special guest because because some people don't agree or know about what I talk about. So thank you. Thanks for having me.
Yeah, absolutely, man. I'm a big fan of yours. I really like the way that you explain the flat Earth concepts and theory. Let's say. So I think it's it's very good to have people like yourself, that take the lead and who are, let's say, the face of the flat Earth. Like maybe you and Witz gets it.
Austin Witz, yes,
Watson, exactly. But I think you are probably the most widely known. And you also have the Flat Earth app, by the way, guys. If you don't know, Dave has a very nice app with all Flat Earth stuff. If you're interested, Exactly, right there, over there. And today we're going to discuss, I think, two big topics. So we're going to start with the DOME shot, which is a token from the Flat Earth app that exists in the PulseChain network. And we're also going to probably be talking about Flat Earth. I want to give people an opportunity to ask you any questions about the Flat Earth if they want to, of course. Let's get started, man. So first, Dave, maybe a little introduction about yourself, how you started, in crypto. Why did you choose PulseChain? Because it's still a pretty not a widely known ecosystem. It's pretty small,
when Bitcoin wasn't widely known and it was on Mount Gox or whatever, nobody knew about it, and people were like, well, why would you do that? I was actually someone that said that. My son's like, hey, Dad, can we mine Bitcoin on the computer? And I'm like, what the hell is that? And he told me, and I looked at it. I was like, it was $3 and now it's $7. You missed it. Right. And so we didn't do it. so why did I choose PulseChain? Because I can see through the charade that Richard Hart was putting out there. He's a master at publicity. He made himself look a little crazy, but if you look at what he's done, I contend to this day that he is the smartest coder in crypto. I think he's the smartest guy out there. So he saw that the Ethereum blockchain was just, my hex that I got in a hex on day one, and it was extremely expensive to unstake. It's like, wait a minute, people that have small stakes are going to cost more to unstake it than they're even getting. And so Richard came out with the PulseChain. I was big on the sacrifice to get in there, and I think it's the future of crypto. That's me. I could be wrong, but the other thing is, excuse me, we did an airdrop on 9/11 for the app, and we offered 33 million DOME for which we wanted to be just around $10 airdrop, so it was 33 million out of a trillion DOME, and for people that registered on the app to receive.
I got mine, by the way, so thank you.
You got your 33 million. Yeah. And so that 33 million is worth like $140 today.
Yes. Okay? Yes. I'm still holding everything.
Yeah.
To the freaking moon, please.
Yeah. Well, to the dome, because the moon is below the dome. We're going to the dome. We're going up here.
I want to go questions
beyond the dome.
Just last thing, I was making a point. I just don't remember my point. So we did this airdrop. If we did it on the PulseChain, we sent it out to about 1,500 people got the drop, and we're going to be sending out tons more because we have this whole referral system. It would have cost us like $20,000. It would have cost us like $20,000 to do that. It would have been like $1.50, $2 per transaction, but we sent out all 15,000 transfers for less than $2 total. Okay, and it worked beautifully. So God bless Richard Hart and the PulseChain.
But regarding crypto, what was the reason? Okay, you already told us that your son introduced you to crypto. What was the reason for you to join, and when did you join crypto? What was your process on it?
So that's a great question. The date. So when was Hex launched? Because I was in crypto for maybe 2 years before Hex, maybe 2 or 3 years.
2017.
So whatever that date was.
Hex was like 2019, so around 2017, something like that.
Somewhere around there, maybe even a little earlier, where I was dabbling in it, bought some Bitcoin and stuff. So that's how I got in. And why did I get in? Is because for those of you that don't know me, I had a podcast called Deep Inside the Rabbit Hole. We spoke into many of the deceptions that are going on in the world, from 9/11 to everything else that we're not allowed to talk about. And the thing that got me into that was I looked up what is money, and I saw a show called Money Masters. I recommend everyone watch that. It's on YouTube. It's an old video about what is money, and I was like, money is complete and total nonsense, right? As Richard Hart says, our fake internet money is better than your fake internet money. Okay,
exactly.
And because the money that we all use here in the United States, and it's probably the same everywhere else, is lent to us by a private bank. It's made up out of thin air, right? At interest. It's all ridiculous. And here in America, they're just printing more money. So they're literally diluting my money constantly. At least with crypto, you have something, there's 21 million Bitcoins. There's actually less because people die and lose their Bitcoins and everything else. So we came up with the idea that actually the mastermind behind this is my co-host, Matt Long, who came up with the Dome. And we just partnered together because the app that I have has a large community, and we're trying to onboard. We have over 200,000 people on the app, and we're going to onboard them all onto the PulseChain.
Nice. Yeah. It's great to hear that. that.
Here is just a quick, just to show you guys. This is here's the UK. Right,
how many are in Portugal?
In Portugal,
down.
Yeah,
over there. Yeah. There we go.
There's a few already.
There's a few. Yeah. They're coming. This is just the beginning. This is just the beginning. Yeah. but here's the thing. Let me ask you guys a question. This is a meme coin, but it also has functionality. It also has a use case, and we're going to have a whole store on here where you can buy stuff with it and all sorts of stuff. So
it's like a reward system, right?
We're actually setting up some farms where you're going to get a reward coin. Also, that's a whole nother thing. But what do you need for a good crypto? You need a large community that is passionate. Who's more passionate than flat earthers, right?
Sure.
And when you become a flat earther, nobody leaves. Nobody leaves flat earth. It's not a cult.
True.
But it looks like
no, it's even worse than a cult. It's even worse. It's even more aggressive
because you can't leave. You can't leave, right?
Exactly, you cannot leave.
Right. And nobody ever wants to leave, other than my family has disowned me and my girlfriend left me, and But guess what? If you can't find people that can see reality, it's probably other people that you need to be with. I always say, someone says, my friends are like this, and my answer is time for some new friends, right? Time for some new friends. Sure. So we have a community that is, the potential for our community is every single thinking person on earth that has an internet connection, right? That's the crypto market. So the flat earth market, and people are like, oh, flat earth is stupid. One day you're all going to see. It's going to happen overnight, right? And so
that I've seen a huge intersection on Twitter between flat earth and hexicans. So I don't know why, just a coincidence, but there's like a huge load of hexicans that are flat earthers.
Well, here's the thing. Like Brandon Davis, what's his channel? What's his channel?
But I know the name for sure.
Yeah.
I've seen him for sure.
I've done a couple shows with him, and the first show he did, he's like, I don't know about flat earth, but then he looked, he listened. He's people in crypto are smart. They actually have the ability to think, right? Because most people go to school, and school just teaches you what to think. They don't teach you about crypto. They don't teach you about taxes. They don't teach you about being an entrepreneur, but people that can think and use their brains and can create for themselves. So crypto people are able to think outside of the schooling, right, which dumbs you down, makes you memorize and regurgitate. They're also able to look and break the paradigm of the globe lie, the globe prison for your mind. So I think that there's going to be, people in crypto, there'll be more and more, there'll be a higher percentage of flat earthers in crypto because those are people that are willing to think. With that said, Richard Hart thinks flat earth is the dumbest thing on earth. But
sure, that's fine. And that's absolutely fine.
He's a busy guy. He hasn't looked into it. I just know, Someone says, all right, teach me about flat earth. You got 5 minutes. Go, enjoy your ball. See ya. Right? Enjoy your ball. See ya. Right?
A question about DOME.
Yeah, go ahead.
Why did it was created? It just became a meme coin? Did you create a meme coin and then try to arrange a utility, or do you have some utility in mind? Just from the
here's the utility. Here's how we distribute it. When on people that have the app is the best way to wake people up to flat Earth. Right, so people can gift the app. It's $3 to gift the app. Okay, so hey, I want to gift it to you. I can spend $3 and send you the app, and now you have the app. If you gift the app to somebody, and then they use your referral code, right? Everyone, if you go in Friend Finder and then you click,
I'm going to gift the app to Malman and Kiko, by the way, just for fun.
Yeah. But let me just tell you. Check this out. Hold on a second. Why is that doing it? Okay, so we go into the Friend Finder, and then we click this button right here. This is your referral area. So my referral code is DITRH, stands for Deep Inside the Rabbit Hole. And so if I gifted you the app, or you bought the app yourself and you use my referral code, I get 1.5 million DOME sent to my wallet address right here. Okay,
but
automatically.
Who does send the DOME to you?
The contract, probably.
The contract. We have it. We have a bot that will pick the DOME and send it. Now it doesn't go in real time right now.
How many DOME are still for distribution? There is a cap limit, or
there's more than half. No, there's 1 trillion DOME total. Okay, there's 1
and
trillion.
The supply is kept.
And the supply. If you go on our website, domeshot.io, it gives you the breakdown. Now, we'll talk about that in a minute. But so by waking people up to truth, you're mining DOME, right? Sure. But here's the beauty thing. 1.5. So it's 1.5 million until Christmas, and then after Christmas we have the flattening. Okay, like the halving, okay? we have the flattening, and that's going to go down based on the price. We were thinking it's going to go down to 1 million, but guess what? Right now, a $3 referral earns you $7 in DOME.
Smart.
Okay,
I'm going to refund
smart.
everybody.
That is, you could do some great arbitrage right now if it was in real time.
I'm going to arbitrage DOME. But yeah. My problem is that I'm not going to sell the DOME. So, you see, that's going to be the problem.
I'm all about dollar cost averaging. But here's the thing: I tell people, listen, if you think, there's a lot of people that are anti-crypto and that are on the app. They're anti-crypto. I'm like, learn how to set up a wallet, get your free DOME, earn some more DOME. And you have nothing to risk because you want to refer people to the app anyway. You want to wake all flat earthers. What do you want to do every day? You want to wake your friends up to flat earth, right? So we've monetized it where you can make some money too. You can make some money doing it, right? If you looked at the chart, the chart's crazy. We're almost hit 5 million market cap last night.
Sure.
Right?
Yeah,
and we haven't even started yet. We're just starting. Okay. People don't even know how to buy DOME. There's people that want to buy it that can't, that they're like, I haven't figured it out. They haven't figured out, the bridge yet. Yeah. Bridge.pulsechain.com. Send some ETH over and then there you go. And, or OX Coast, exchange. You can buy their coin. You can on-ramp some money there. And then you're on the Pulse chain.
Who is selling the DOME? It's an open market or
open market?
It's liquidity providing. It's like like.
So you did this distribute all the DOME for free, and
we have we have the
origin address.
The origin address has DOME in it, and that is what's going to be distributing to the people as they do referrals. But right now,
who controls the origin address? Who controls the origin address?
Here's the thing. You know how Richard Hart, they're like, Richard, you could dump everything, So exactly. There's even flat earthers, great flat earthers out there. They're like, this is a rug pull. Everyone stay away. And I'm like, I've spent 10 years building my reputation so I can put out DOME and then yank the rug out from everybody and have the world literally hunting me, wanting to kill me. Okay. Sure. That is
sounds like a good plan. A very good, very smart plan.
My plan is to never sell any DOME. Okay. Sure. Never. Sure. Except maybe to fund something inside of, who knows, a little bit, but there's zero chance that I'm going to push the price down at all. I'm going to push the price up. But I tell people, you can buy some if you want. People say, Dave, I'm new to crypto. What do you think I should buy? And I say, don't buy anything ever. That way you can never blame me for making money or losing money. Okay. It's like, don't buy anything. I go, but here's what I'm buying. Okay. Here's what I'm doing. Here's what I'm holding. But it's like, I've learned, I've recommended things. I'm like, oh, that didn't work out. So I never tell anyone. I just say, you got to figure it out yourself. You got to look at it. And, don't, my saying is don't chase green candles. Okay.
Exactly. No, that is very smart always, right, guys? Like, even if it's something that you love, never avoid buying when there are a lot of green dildos, right? Don't
Yeah.
It's retarded. I have a question for you, man. It's a bit unrelated to DOME, but I never heard you talking about this, so I'm just curious. What's your opinion, and like, do you like privacy coins like Monero, for example? Is it something that you like, that you hold?
I love Monero. I have a good amount of Monero, but you'll never know.
Well, don't say that, because Kiko is a huge Monero fan, and I'm sure one day he's going to break the privacy of Monero.
You know what? Everything gets hacked eventually. So
no, sure.
Except Richard Hart. I think that except Richard Hart stuff, his stuff doesn't get hacked. Like the guy,
immutable. People don't like, people underappreciate something that's immutable, actually. So
we're gonna have our friend Riklas joining us.
Welcome, Riklas.
Hi guys.
Hey man.
How are you doing? Hi Dave.
Good. I'm doing great. So
besides myself, I think Riklas is the only flat earther, that we have on the podcast. So, well, I'm kidding. I don't think he is.
At some point, the people that aren't flat earthers, I want you to think about it while we're talking about DOME, and tell me why you think the Earth is a globe. Because if you really think about it, you're going to end up being a flat earther.
Sure. Absolutely agree.
I do have questions about the app. You are talking about the app. What does the app do, and why did you create it?
So I when I would be talking to people about flat Earth in 2017, I'd be trying to explain things. And I'd be looking for a video on YouTube. I'm like, God, where is that? Where is that image? And I said, you know what? I had created an app before, and I was like, I'm going to create this app, and I wasn't even going to publish it. I just had it on test flight, and I would show people it, and they'd go, where do I get that app? Where do I get that app? So I put it in the store for free. And people were like, hey, can you add this feature? Can you add that feature? So I started adding more and more features, and it started costing me money. So I said, you know what? Let me charge $3 for the app. That way I can just fund more stuff. And I learned, I used to think, all right, that's it. The app's done. That was in 2018. The app is never done. There's always more and more and more stuff. I mean, if you look here, this is these are all of the different pages on here, all of the different functions. Like, I now have a dating site on here. I've got a DOME. Literally, you can find other people within a radius that match your. You choose your age group, you choose your radius, and it'll show you other flat earthers. Guess what? No dating site will find somebody that's well matched to you, because you guys don't realize this. If you're a flat earther, you can't date somebody that's incapable of becoming a flat earther. You can't. All right.
Sure.
So one of the big things on here, YouTube is so censored. Where you Google flat Earth, you find nonsense. You find
that is true. That is absolutely true.
But every day there's a featured video right here. So my challenge is I have a 3 Bitcoin challenge, right? And is watch the daily video every day for 2 weeks. At the end of that 2 weeks, if you think the Earth is a globe, send me one proof of the physical globe, and you win 3 Bitcoins. Okay. People are like, you got to have your Bitcoin in escrow. You got to have a contract. No, I don't. Okay. My honor. Okay. My honor is on it. But here's the thing.
The problem that I have with flat earthers, nothing it's a proof for you. So what will be a proof for you?
Actual curvature, axial, or proof of axial rotation. That would do it. Curvature proof.
That's
or
super
axial
simple,
rotation.
Come on.
Yeah.
Go find it.
Yeah. Go find the curvature. Because the curvature, well, the Earth is too big for us to see the curvature. We're just like microbes on a basketball, right? Nonsense, right? Because the Earth, the size that they claim it is, has 6 feet of curvature at just 3 miles. At 100 miles, there's over a mile of curvature, right? There's so many things that I could show you. There's so many proofs that absolutely do not work on a globe. I tell people, and if you want to learn more, just go to flatearthdave.com. You can find the app there, or you can scroll down to where it says Crash Course. Big picture of me says Crash Course. Watch those videos, right? I say, if you don't want to get the app and do the challenge, watch the first 5 videos in that free list, all free, hidden videos that Google will not show you. And watch those. At the end of those 5 videos, I would say send me a proof that the Earth is a globe, but you're going to send me an email going, "You've ruined my life." Everyone thinks I'm crazy because I told them the Earth is flat, right? But
like
it's growing.
Someone shooting like a rocket into space and streaming it live, would that do it for you?
Yeah. Have you watched the rockets that Elon has put into space recently? Did you watch the one that they just caught, the giant one?
Yeah.
Yeah, and you think that's real?
Yeah.
You actually think that's real?
Yeah.
Have you looked at? Can I share my screen? Can I share my screen?
Sure.
Yeah, Maman, can.
No, you just have to share and I accept.
So what you're saying is that you think no rocket has ever gone to space?
Oh no one has ever. No human has ever gone on a rocket to space.
But I have a couple of questions. Then maybe you can answer me, because I tried to find answers for this, like from the flat Earth. So like, there's no space,
right?
Yes.
Is that
there's
it?
like probably water or something like that.
So you think it's like a dome, right?
Well, there is some sort of enclosure. There is some sort of closure up there.
Planets and the moon and shit is all like a projection or something. And who's doing it and why?
Well, these are questions that nobody can answer. Like, what's under the flat Earth? Well, what's under the globe? The deepest hole ever dug is just 8 miles, right?
That's not my question. My question is like, okay, you believe it's a dome, then
I believe there is an enclosure and there is evidence.
There's an enclosure, but then who built it and why? So this goes into a realm of like
who built the Earth,
right?
Who built the Earth?
Well, I think it's just like randomness.
And then our eyes evolve so we can see things. Yeah, you really haven't looked too much into this. I used to be just like you, by the way. So don't think I'm making fun of you, but I am. I actually am a little bit.
I'm asking like serious questions. I've looked into it for a bit, like it may be like around that time, 2016, 17, right? And I was just not convinced, right?
Yeah, well, you haven't looked enough.
It raised so many questions, right? That none of you guys tries to like another question is like, no one has gone to the limit yet and like touched the dome, right?
Well,
and just like take a picture and send us all. So
eventually you have to let me talk at some point.
Sure. Sorry, I just have so many questions.
Yeah, well, that's the problem. You ask a lot of questions, and then it takes time to hear the answers. And the answer is that the scientists in Antarctica, they do go out to the outer limit, we believe, and they test what's called sky ice, but they never let us see this sky ice, right? Am I sharing this video, by the way?
Like,
can you see this?
Why wouldn't you guys from the flat Earth community, like, crowdfund a fucking, get research into it and crowdfund a fucking boat and just go there and like show everyone?
There are people going. There are people going to Antarctica. Yeah, there are people going this winter. But it's under a false premise, and that's a whole other thing we don't need to get into here. It's people going there looking at the lights in the sky, trying to prove the shape of the Earth. That's what globers like to do. They like to look at the lights in the sky.
No. I'm telling you, I'm saying like get a cruise like from the community that goes there to prove that there's a limit, to just like touch it and like send a picture to everyone. So we all believe you guys, right? I want to believe you guys. I really do, but I want to see like some evidence for it.
Well, there it comes.
You're sharing your screen now, by the way.
I unfortunately I don't see. No, why? I wanted to be able to stop this. So watch the thing. This thing is free falling out of the sky. It weighs tons, several tons. And then watch the clouds. Watch the clouds as it goes through the clouds. The clouds are going to morph, right? Watch the clouds. Watch. You see that morph? See that morph? What is that? This is a projection.
Sound barrier. It's the sound barrier.
No, that is not the sound barrier.
It is.
Way.
This is all projection.
But like, if there's no gravity, like you guys say, it's easy to do this, right? You just need to control whatever, like electromagnetism or whatever.
Yeah.
Right?
No.
So why not? No.
Okay. No. So here's what I say. Wait, hold on.
I have a question for you, but if you want to
let me just say the guy that was just talking. Let me just say one thing. You're not going to learn about flat Earth on this podcast, right? On my website, flatearthdave.com. Go to the website and scroll down to where it says interviews. Now, also the crash course, I highly recommend that. But if you go to my interviews and watch 10 of them, that's a lot. It's a big call, right? You got to turn off Netflix for a couple of days, and watch the interviews. I'll show you all of these things. Like how does the sun set over the ocean, right? Why do boats disappear from the bottom up? I have answers for all of those. And I can show you a few things here today that don't make any sense on the globe if you guys want to see. But where are we going from here?
Okay. Dave, on your view, since we are talking about flat Earth, what is the weakest argument against flat Earth that you think that don't hold up very, very well in community?
Well,
how do you know?
Right. The anti-flat Earth globe trolls out there will say, flat Earther will never address the sunset over the ocean or why ships disappear from the bottom up. Actually, we have fully explained it, but they just like to say that because weak-minded people that are lazy and haven't looked.
I'm not talking about what the other people tell to you.
You say the weakest argument. I'll give you their best argument. Their best argument is the sun in Antarctica, the sun, whether it circles in Antarctica or not. Now, we don't know if the sun circles in Antarctica, but in December, if the sun sets in Antarctica, it 100% proves that the Earth is not a globe. Unfortunately, if the sun does circle in Antarctica and not set, it just tells us that we don't understand the sky. Right? Because we're not measuring the sky, we're measuring the Earth. And the Earth at 24,901 miles around has a certain amount of curvature, and it doesn't curve. It doesn't curve at all. Right? And in the heliocentric model, we are corkscrewing through space. You know what that means? We're spinning in
spiraling out.
We're spiraling in all these different directions. So, in the heliocentric model, we're orbiting around the sun at 66,600 miles an hour, right? We're chasing the sun. Yeah. We're chasing the sun at almost 500,000 miles per hour. We're spinning, traveling 4.5 billion miles a year, never to return where we were before. So it's gone trillions of miles, and none of the stars have ever changed. Every star is in the exact same orientation, right? This is called parallax, where you have two stars, and as you move, they would change positions, and it's never happened. No, they never. No star. They don't. No, we don't. We have precession of the equinoxes, but the stars are moving.
Yeah, exactly.
But they stay in the exact same position. So the closest star to us is 25 trillion miles. So hang on. I'm in the middle of talking. I'm trying to explain something, and you're interrupting.
Sorry.
Okay. So the problem is, when globe minds don't like to listen. No offense, but it's true. I was a glober once. I was a glober.
Yeah, I'm sorry.
Right? So the closest star is 25 trillion miles away. Do you know how far that is? Right? How long do you think 1 trillion seconds is? Just so you can understand how far that is. How long is 1 trillion seconds? You want to guess? Take a guess. Random guess.
Few centuries.
Yeah, it's 31,000 years, okay? 31,000 years. So if we're traveling at a mile per second for 31,000 years, we're 1/25th of the way to the closest star. So the Earth has gone farther than that since stars were charted. So do you think that the orientation of the stars from the point of view of that star would be different? Of course, everything would be different. And never once have two stars changed positions. You guys familiar with the Georgia Guidestones here in America?
Sure.
Yeah, are you familiar with it?
No, I'm not.
So the in Egypt the pyramids have a shaft that if you look through it, Polaris is right lined up in that shaft, right?
Mm-hmm. Yeah.
The shaft is closed, actually.
Well, but you can
see shit. Yeah. But
you can't. But they say that
somewhere. It points somewhere. Yeah.
Yeah, but they say that when it was built, it was pointing towards another star, and it just happens to be pointing towards Polaris now. But we had a different North Star back then. That's the official story. But here in Georgia, we have the Georgia Guidestones, which is this tall monument, and there's this little hole right here. When you look through it, there is Polaris. Okay, Polaris is in that is lined up in there. Now, okay, they say even though we go 190 million miles from one side of the sun to the other, back and forth. We're chasing the sun at 4.5 billion miles a year, right? Never to return to where we were before, but the North Star never moves because it's so far away, there's no parallax, which is ridiculous. But okay, we'll give it to them.
But the North Star moves.
No, the North Star does not move. It never moves. And I'm going to prove it to you right now. I'm going to prove it to you right now. Okay? So the Earth, there supposedly wobbles, right? It has a wobble. So that would, it wobbles 1 degree every 67 years. Okay. That's interesting. So so it has a 26,000 year wobble, right? So as it wobbles, it's moving the axis. Well, the full moon in the sky is 1 degree. So I'm sorry. Three full moons is 1 degree in the sky. It measures 1 degree in the sky. So 3 full moons above you. So the Georgia Guidestones show Polaris in here. It was up for over 40 years. So 40 years means it's wobbled more than 0.5 degree. So that's 1.5 moon widths, which is more than enough to knock it way out of this hole. But it was still there. So we started making videos about it. And it started going viral. And guess what happened? A terrorist out of nowhere blew up the Georgia Guidestones, stole the time capsule underneath it. 3 hours later, a construction crew came in, knocked the whole thing down, and there was never any investigation. Because that was what we call rock solid proof that the Earth is not moving. So they got rid of it.
I believe there are new Guidestones, not Georgia, because they're made in Japan now, I think. But there's a new one at least.
Yeah, and besides all the other stuff, the Georgia Guidestone saying that keep the population under 500 million. That's an interesting thing. But again, these are things that absolutely prove that we're not on a ball. Can I show you another one? Another one which I like, one about day and night. I'll show you. So this is going to take about 2 minutes. So just pay attention, right? So if we have a ball, if you go in the dark room, you got a basketball or a globe, okay? And you got a bright light on the other side of the room. That's the sun, a spotlight. No matter how you turn or twist that ball, the light's going to light up exactly half of it, right?
Sure.
Okay. So this is from the Weather Channel. And they said on this day that 70% of the Earth is in daylight at the same time. And so they had to make it like this because this is where the continents are on a ball. So let's take a look at what that looks like, right? So here is on April 13th. Let me go back. April 13th. Where'd it go? Hold on a second. Why isn't that going back? All right. Yeah. August 13th with the sun right there. It had this light pattern. So I'm going to take this light on this flat Earth map and we're going to turn it on and lift it up. And we're going to show you that there's the light pattern. So on this day, you got America, the West Coast, California is just about to go into darkness. South America is all in the light. The only thing in the dark is Australia and these islands. All right. This is the actual light pattern from time and date. All right. This is the actual physical, observable, testable light pattern on the Earth. So we can create that same light pattern with a light here. Pretty close, pretty damn close, right? But if we try to do it on a globe, watch what happens. So I got a globe here and we got a bright light at the end of the room. And so over here, carefully watch. So here is Australia and we'll put Australia right there in the pink and it's in the dark. So Australia is right there in the dark. So we got the line, we got it set up. So we go to the other side, we have a problem. Because all of South America, all of America is in the dark. So let's realign it from this side. So we'll spin it. Remember, California was just about in the dark. So we'll move it. California, just on the edge of darkness. South America is all lit, right? And we go back to the other side. And all of Russia, all of this, watch, all of this is supposed to be in light. I'm going to spin it out. All of that should have been in the light, but it's not. So I just showed you that on the globe map, the globe physically doesn't work. But
yeah, but you're basing all of this on like the Weather Channel. Like,
no, I'm basing it on actual observations. The Weather Channel is showing. Exactly. This is not the Weather Channel. Mm-hmm. This is a website you can go to. It's called Time and Date, and it'll show you at exactly what time, any day, where the light patterns are, and all of it can be verified. You can go on this date, set it to this time, call somebody here, and they'll be like, "Oh, the sun's just rising. Oh, the sun's just setting." Right? Yep. This is actually provable.
Dave, can you maybe talk a little bit about time zones as well, because that's a very doozy one, I think.
Yeah, time zones. So who's the guy I'm talking to? That's time zone guy.
Me?
I mean, not the time zone guy. The guy, the globe guy. The globe. What's your name?
Kiko.
Me?
Yeah.
No,
He-
I'm not the globe guy.
You're not the
flat
globe guy.
earther.
He's the questions guy.
No.
He's the questions guy.
I'm a flat earther wannabe believer, but I've just
All
not
right. Well,
found the
no, I
evidence
got.
yet. But you're doing a good job. So
All right.
keep it up.
Hey, I appreciate that. So time zones, right? So let me.
Sure.
So time zones are on the globe. You have the North Pole and the South Pole, and then you draw 24 lines, right? And as the Earth spins, wherever the sun is, it's noon. So when the sun's right here, it's noon in this time zone. When it's here, it's noon. So that's how time zones work, right? So a globe has symmetry from north to south, and that's how time zones work. It makes perfect sense, right? It makes perfect sense. And they say that the sun is so far away that all the lines are coming in straight, but they forget that the Earth is tilted, right? So if the Earth is tilted, it doesn't follow the time zones, right? So that's weird. That's just weird. Like, why? How can the time zones like this? This should be 6 p.m. Let's say. Well, how can it be 6 p.m. in this time zone and this time zone and this time zone and up here? That doesn't make any sense. Here's the interesting part, right?
The time zones are
Wait.
We're
Getting to the good part.
There's 19 time zones in the north, in the Arctic area. There's 24 time zones between the tropics, and there's 32 time zones in the outer south. How is that possible on a ball? Now, if you took this map and wrapped it around a ball, you'd have to get rid of some of those time zones. But since we're not on a ball, you have these extra time zones.
Yeah, but I do believe that time zones are more social than actually measuring the light, because even here in Europe, I believe that Germany and France and Spain all have kind of the same time zone because of business, not because of the light.
Yeah, well, that's what they say, and they say it's for political reasons and everything. Why are there 32 time zones, right? Why are there 32 time zones? It makes absolutely no sense, other than if
some are like, just conventions like UTC, right? Or, whatever. Like India uses 4.5 hours away from Europe. It's not like even 1 hour. It's 1 hour and a half.
Right, but there's 32 hours worth of time zones because they can't have huge swaths of area that are in the same time zone when they're not. When the sun will be in a massive different position. So that's one of the ways that they hide it from you.
That's a good point.
Yeah.
There should be the same number of time zones.
There should be the same number of time zones, equally spaced apart, equally spaced.
Even if you choose your model,
one, right?
What's that?
How many time zones should there be on?
There should be 24 time zones, equally spaced
on the flat Earth?
On the globe. No, on the flat Earth.
No, on the flat Earth. Yeah. What would be like the model?
The model would be, the problem is in the flat Earth, the time zones get wider and wider and wider as you go south. Well, guess what?
Sure.
The distances get wider and wider and wider. You know that all sailboat speed records are made in the north because GPS in the south says, oh, you went 100 miles. And in reality, they only went 50 miles. Am I saying that right? No, they went 200 miles, right? Sure. In the north, they're going 50 miles when it tells them they're going 100 miles, or it tells them the accurate amount. The problem is that the sailing records are all made in the north when there's more wind in the south. There's more wind in the south, right? If you look at the Antarctic sailboat race, which a lot of people say, it goes around Antarctica, right? Well, it's actually not anywhere near Antarctica. And last year, on their website, they showed one leg of the race, and it said that the one leg of the race was 32,000 miles. Wait a minute. The equator is only 25,000 miles. How can that one leg of the race be 32,000 miles? It makes absolutely no sense. It makes no sense whatsoever. and they hide it. And we even have
but they're
we even
not
have
sailing in like straight lines, right?
Yeah, well, no, it doesn't matter.
Land
The distances that they go, if you look at the winners of that race, the average speed, according to GPS, because that's the only way to measure, and GPS is run by NASA, the average speed is 4 miles per hour. Okay? That's like winning the, Indianapolis 500 car race and only going 25 miles an hour. Right? It makes absolutely no sense whatsoever.
But have you ever sailed?
I'm a sailor, absolutely.
Against winds, and
yes, I have.
Like go on an S, right? You can't really do a straight line on the sea.
It doesn't matter. It's tracking where they're going, right? These boats go 20, 30 miles an hour, easily, right? These are the fastest sailboats in the world. 4 miles an hour, I'd kill myself.
Especially where like
right.
like I think the point that Dave is making is like for example, Kiku, sure, you should be like in some days or specific times, right, the wind could be against you, right? But what Dave is saying is that it's always in the north that you have the records, in never in the south, although
they're always going with the speed, they're always going with the wind down there. Here they said from the tip of South America, of Africa, around Antarctica and over here to, I think it's Buenos Aires or whatever, is 32,000 miles. Wait a minute. The entire circumference of the Earth is only 24,900 miles. How is that leg?
It's smaller on that end, right? If it's a globe, it's tinier on the bottom, right?
Down the bottom, absolutely. So how did they go? How come it's 32,000 miles?
Because it's going all the way around and not like on a straight
line.
So
if you took this line, you think this line is bigger than the circumference of the Earth. You are just making excuses without thinking.
No. I'm not. I don't know the numbers, right? I'm just.
I do. I've looked.
Okay.
Yeah, I've looked. Do you know what the radius of the Earth is?
I don't know by heart.
Do you know the distance to the sun?
It's
90 million miles or something. Right?
I'm at
6 minutes for the light to get here.
8 minutes. It's actually 8 minutes, but that's just the theory.
Speed of light and get
that's just the theory.
Yeah, that's the theory.
Right.
Yeah.
Right. So here's the thing: globe believers don't know a tenth of what flat earthers know about the globe model. That's why we became flat earthers. We studied the globe model and we're like, this is just stupid. It's ridiculous.
But you did talk with a lot of round hearts. Whatever. What do you consider their best argument against the flat Earth? Do you have any argument that people used to tell you and make you think about it?
Yeah.
What makes you doubt the flat Earth theory, basically?
You mean doubt I'm beyond doubting the flat Earth, but I'm always open to new things. Here's the thing. Whenever we measure the Earth, it's flat, it's level, it's horizontal, it's not moving. And the globers like looking at the stars and say, the stars prove the flat Earth. No, the stars prove that, if you actually think about the stars and the planets and look at the math of what they are, where they tell you they are, they would be impossible to see. Impossible to see. Like, you guys ever look up and see Jupiter in the sky? Jupiter?
In the summer, sometimes.
In the summer, and it's super bright, right? It looks like a star. It's super bright.
Like, it's way brighter than anything else, right?
Yeah,
but it's reflecting sunlight from
Okay, so think about this. Jupiter is a dirty, gassy planet. So the last time I looked, gas doesn't really reflect light. It kind of absorbs light, but whatever. So if you were on Jupiter, you're 4 times the distance from the sun than we are. Okay, Jupiter's 400 million miles from the sun. We're 93, so it's 4 times the distance. So the sun would be tiny. The sun would be like the size of the end of a pencil eraser. Okay.
No, but the sun is way bigger, right? Than Jupiter, like way bigger.
You're not listening to what I'm saying. You're trying to make up an excuse. You're trying to make up an excuse.
I misunderstood. I'm sorry. I'm asking a question.
Yeah. So from Earth, the sun is this, imagine this. The sun is gigantic next to the Earth. The sun is one of those big yoga balls. The Earth is a tiny marble.
Yeah.
And if the sun was a mile over your head, it would fill the entire sky, right?
Sure. Yeah. It would be very close. So yes.
If it was a mile over your head, the entire sky would just be the sun, right? Because that's like, it would be just the whole sky. So we move the sun 93 million miles away, and it becomes the size of a coin held at arm's length. That's because it's getting farther away, it's getting smaller. So if I doubled the distance of the sun, it's now a quarter of the size. And if I doubled the distance again, it's now a 16th of the size. So the size that we see the sun from Earth, from Jupiter, the sun would be 1/16th of that size. You could almost say the sun would almost look like a star, but maybe a little bit bigger, right? So you have to believe that distant, fainter sun is reflecting off of Jupiter. And then that light is reflecting off of the non-reflective gas going 400 million miles back to your eyes, and you see it that bright. You're not thinking if you think that's true.
Sun is really bright, yeah. So even when sun is far away, if it's really bright, you can have a small lamp lighting a really big room, I think. And Jupiter, it's a big planet, so I don't see that as a problem.
So you guys know what the inverse square law of light is?
Works, right? You know how light reflection works, right?
I do. Do you know how the inverse square law of light works?
Okay, explain it to me, please.
So when you have a light, it's a certain brightness. So this guy's showing you at this distance, the light is here. Let me just fast forward. So he just doubled the distance to the light. So it's actually spread out over 4 times the area. It's hard to see. He drew 4 boxes there. And then he moved it, he doubled the distance again, and now it's 9 boxes. So all of that, as it goes farther away, it gets dimmer, right? Because light spreads out. Light spreads out as it's going. So it gets dimmer. So when you're on Jupiter, the sun is smaller and it's less bright. And then it's reflecting off of the gas clouds and coming back to you on Earth, and we see it as bright as the sun. It's like a bright, bright star. That's impossible.
Not as bright as the sun, but
it's like a piece of the sun, right?
Sure.
Do you know that the moon, for us to see that the brightness we see, would have to be 60 times brighter than the sun from 100 miles away for us to see it at the brightness that we see it? If it was 1 lumen, the inverse square law of light says from 100 miles away from the moon, it would be 60 times brighter. Could you imagine the sun twice as bright? No, you can't. You've never seen anything that bright.
Also, doesn't since the light is traveling on the vacuum, does helps the light traveling? So there's the right
less friction, or there's no atmosphere or anything interfering
with
the light.
You can say that all you want, but it doesn't make it true.
I'm not saying. I'm just making assumptions.
Sure, but that applies to both sides, I guess.
Yeah, exactly.
But I think like imagine this. And honestly, this is not like, for me, this is like logic.
No, but
right?
I think
it's not about being right or wrong.
We should do a DAO and crowdfund a boat so we can go to the edge and just prove you guys are right.
Well,
that would be a problem. You couldn't go. Like even if I want to go, even if I want to spend all my money going there, right?
But
all my hacks, all the hacks that I accumulate, I'm gonna sell everything just to go to Antarctica. I can't go. Right, because there's
I don't think that's true. If you really want to go, you can.
You can, probably. But that's a point.
You can.
No, you can't.
Who gonna forbid you?
You can't. You can.
Who gonna forbid you from going? That's
the treaty.
Well,
the military.
It's the Antarctic Treaty. All of the countries in the world that are fighting over resources and everything else, they all agree that there's no independent exploration of Antarctica. Right? You can spend $30,000-$40,000 and go to a little ice camp and see some penguins and some ice for 3 days, and then they kick you out. But there's no independent exploration of Antarctica. So what's out there? I think there's more land. I think there's more land.
Yeah, I cannot just grab a boat to go there. That's my point.
Does anyone try to get in a boat and go there?
Yes, there's videos on YouTube, and you can see what happens.
There's been a few expeditions that were more or less trying to be independent, but a long time ago. They mostly died trying to do it. Yeah.
Yeah. Well, the the other thing is they want you to think that you can go there, but it would cost you like $2 million in permits and in fees, and then after a couple years they'll deny it and they keep your money. No one's going to Antarctica and independently explore. And the people that have gone and supposedly circumnavigated, when you actually look at the data from their trips, it's nonsense. It's absolute nonsense, right? I'm just showing you here how the sun sets. This is not the ground. The atmosphere becomes opaque over distance. It all merges together in your horizontal eye zone or your horizon, and it goes beyond it, just like this coin is going beyond this horizontal eye zone. It's the same thing, and it's small and it's local, and it takes its light away with it.
Makes sense.
Yeah.
I like simple stuff, right? So
yeah. Can
you explain that again? I was reading the chat. You are telling me that the coins go down and it's not.
So this camera is slightly lower than the table. Okay. Now you would think, oh, I'm standing at the edge of the water. I'm never below the horizon, so I should be able to see the sun forever. But it doesn't work that way. Here, I'll give you a full explanation. Give me 1 second. So we go, where is it? All right. So here we have, all right. So here I'm in New York City. I'm looking up, there's a 50-story building. It's noon and there's the sun. And so I wait an hour and the sun moves across the sky. And so now is the sun below the building or is it just out of my view? It's out of my view, right? It went beyond the building. Now, there's two ways I can see the sun. I can go up in the air or I can go backwards. If I went backwards, a little ways, I'd have a better angle and I could see over the building because the building would appear to get lower, right? Sure. Understand? That's perspective.
Yes.
So here's a perspective grid, right? And here's my guy. This line is his eye line. And I'll put this mountain here. Let's say this mountain is 3,000 feet above his head, right? So the sun is in the sky and it's going to move away. Now, is it moving below the mountain or just beyond the mountain? It's moving beyond the mountain, just like it went beyond the building. So how could he see the sun again? Well, he could go up or he could go backwards. So we'll move backwards. And so let's say he's 20 miles away right now. And so this line here is 3,000 feet above his eye level. But to him, it looks like it's on his eye level. If somebody was over here on that mountain, they'd be standing 3,000 feet above where he is.
No, wait, but
right?
you have to adjust the horizon line and the whole perspective thing depending on where the guy is standing, right?
No, the guy is here. He's 25 miles away from the mountain. I can see New York City 25 miles away from me.
Is he
and the tops of those buildings,
or is he
he's where he is. It doesn't matter. No, he's on the ground. The
elevation matters towards perspective, right?
He's 3,000 feet below this mountain. Okay? It doesn't matter if he
just goes backwards. Yeah,
it doesn't matter if he's at sea level, the mountain's 3,000 feet, or if he's at 3,000 feet and the mountain is at 6,000 feet. It doesn't matter. From his eyes, the mountain is 3,000 feet above his eye level. Let's pretend he's standing at the edge of the water, at the lake, at the ocean, and here's a mountain 3,000 feet. So we move the mountain away 25 miles, and it's still 3,000 feet above him, but it's above, it looks to him like it's at his eye level. The sun goes away, and is it going below or is it going beyond? It's going beyond, just like it did with the building. And now we add the clouds. Now the clouds, the atmosphere, even if there was no clouds, the atmosphere becomes opaque over distance. It does. Deal with it. It does, right? Yeah. And so the atmosphere is merging into this horizontal eye zone. Now watch this. The sun is above that. So the sun goes away and it goes beyond this line here. Now what is this line? The line is tops of the mountains, which are 3,000 feet above his eye level. And then the atmospheric deck of opacity, the opaque atmosphere, which is 5,000 feet above the mountain. So this line that's blocking the sun is thousands and thousands of feet above his eye level. But this is how he perceives it due to perspective. And that's where the sun goes. The sun just goes and it takes its light with it. To believe that when you watch a sunset, that you're falling over backwards faster than the speed of sound versus the sun just going away is insanity. The sun is just moving away. It's just moving away. And over here, this line here is thousands of feet above their head. See that atmospheric deck? It's just going beyond it, going back and forth here. It's just going beyond it, right? It goes beyond.
That's not how I remember the sunset, to be honest.
Well, because you never really zoomed in on it. When you zoom in on the sun, it looks like the sun's going away, going down, but then you find out it's not even touching the ground at some point. But then, you know, there could be mountains that you can't see in the distance. There could be all sorts of things. There's different ways the sun sets, and sometimes it doesn't set. It just fades away. It depends on where you are.
Never saw it.
You want to see the sun fade away?
Here in Portugal and flat on the.
I believe this is in.
This
is important. This might even be in Portugal, right? Is this cameraman falling forward towards the sun, or is the sun just moving across the sky, coming towards them, like bringing its light with it? Yeah, the sun is moving. The sun is moving, just like we observe it. But nonsense has told us otherwise. Complete and total nonsense.
Can you show that? Can you show that sunset where the video where the sun just disappears? Because there's people in the chat saying it doesn't.
Yeah.
But there's that on video, the sun just disappearing in the atmosphere. So, I mean,
So here we go.
More than one source, by the way.
This is on a super clear day. Now, super clear day. Here's has to be. It has to be no humidity, super clear, and usually like freezing, like 32 degrees Fahrenheit, which is 0 Celsius, right? And so I got my drone up as high as I can get it. And I've watched the sun. Now, the sun was up here, and it was going down, down, down. Now, if the Earth was spinning, it would never stop. It would just keep on going until it set. But it didn't. It went down, 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 and it stopped right here. It stopped, and it sat here for 10 minutes. Now, my friends were at the beach over there, and they said it's already dark, and the sun set from the bottom up 10 minutes ago, but I'm still looking at it. And here's the thing. Whether it's focused or not doesn't matter. Whether I have a solar filter on, it doesn't matter. It's sitting there, and it's not going down. It's not going down. Wait a minute. Did the Earth stop spinning? It sat here for 10 minutes. From here to here, did it in 2 minutes. But from here, it just sat there, and then it did that.
Disappears. Yeah.
It just disappeared. Now watch. I'll go back and forth right here.
I'm sorry, but I just don't buy it.
You can test it yourself. You can test it yourself.
Here's the thing. On my app, I have a whole section where I have 8 videos, and some of them are live streamed because everyone's accused me of Photoshop and everything.
You can do it, bro. You have drones, Malman. Just do it, bro. Do it.
Yeah, you can do it yourself, and other people have filmed it also. Right? Here's somebody that actually filmed it from the ground. Right, the sun kind of just fades out. Look. I zoomed in here. So he's just watching the sun. It stopped going down. It's just sitting here, and then it kind of just disappears into the soup of the atmosphere. It doesn't go down.
It's refraction.
It's going away.
Refraction. I love refraction. I love refraction.
Look, but let me give you a fair point, which is it could be refraction. I'm not saying that's not the point. The point is
you're saying there's a thick atmosphere, right?
No, we're saying that there's an atmosphere and that the sun moves in one direction, right?
This was filmed in Afghanistan by a soldier on a super clear, dry day on a plateau. And you know who this guy is, right? Paul McCartney from the Beatles. Sure. The fool on the hill sees the sun going down, but the eyes in his head see the world spinning round. It's a famous song by the Beatles, right? And they're singing about the sun. Right? Because the sun is just going away, but people see it set. Like if you were down here on the ground lower, the sun already set. It set from the bottom up because it went behind this. It went beyond this ledge right here. So they saw the sun set from the bottom up, but it's still really there. It's still there.
Sure.
Okay?
There was somebody asking for a scientific proof of the theories that you're saying, but I mean, it isn't like the evidence of testing yourself stuff if you want to, right?
Yeah, you know what you do. You should have you should have the anti-flat earthers on your show and let them prove the globe to you. It'll be amazing at the word salad that they'll throw out there.
There's always a point that people get blocked with, I would say, which is the concept of gravity, right? Because it's understandable, right? Like they tell you that there's a force, right? And you accept it because you do feel a force, right? There's something pulling you down, right? And it's very hard for people to accept that there might not be gravity, and that gravity is just a theory, right? And it could be something completely unrelated, right? That's pulling you down, like your weight and the electrostatics, etc., right?
All right.
So maybe you want to touch on that?
What on gravity?
Yeah, sure.
Yeah. So gravity is just a theory, and it is a theory. I'm not the one that says that. They don't know how gravity works. They don't know how magnetism works. But for some reason, we do go down. And now there's a lot of flat earthers that say buoyancy and density are
which makes sense, right?
Yeah, buoyancy and density sort things out, but why don't things go sideways? Why would things go down? I don't get it. Why things would go down, right? And so I'm on the same level with the gravitationalists. So here is and people that watch me know what I'm going to show right now. So here is we got some helium balloons left over from a party, and we got just a button here, and it's kind of neutrally buoyant about a couple inches off the floor. This wire goes to a Van der Graaf generator, and we're going to add a positive charge to it. Now, the Earth has a negative charge to it, and the sky is positively charged. So when we add a stronger positive charge to it, it goes down. Now, do we manipulate gravity, or do we manipulate the electrostatic attraction of two things? Everything is electrostatic. We discharge and it goes up, right? We could do the same thing with a negative charge. Negative and a negative repel, and it goes up. Turn it off, it goes down. Turn it back on, it goes up, it stays up, right? This is from MIT. It's called the silent drone. I think it might have a little hum to it. The globers are like, it makes noise, whatever. There's no wind coming out of it. They're just changing the electrostatic charge. So I've proven right here that manipulating the electrostatic charge of something will move it up and down, right? And the globers, the globalists, the globe scientists say that the electrostatic force, which is provable, it's a force, is 10 to the 36 power stronger than gravity. So let's pretend gravity was real. So gravity is 1, and the electrostatic force, which I just manipulated, is 10 to the 36. You can't even fathom what that is. That means that this is 0, okay? That gravity is a 0. So, when you start looking into these things, they make perfect sense. During a lightning storm, things are measured to fall at different rates. Sometimes lightning strikes and things go flying in the air. Well, maybe that's because it changed the charge of the Earth for a split second.
And there's something that you can also try, like on a very clear day, like super clear day, try pick up your drone or whatever you want. That's something that goes up and put like a copper wire or something attached to it, right? And just make it go up and then touch the fucking copper wire.
That's right.
We'll see what happens. And it's a clear day. There's right. No storms. There's just electricity is just everywhere, right? That comes from Tesla, right? It's nothing
right?
new. This is not something that's new, right? Electricity exists in the atmosphere.
Yeah.
The higher you go, the more electricity there is. So, yeah.
I agree. You want to talk about DOME anymore, or what do you want to talk about? I'm done talking about
DOME.
gravity.
Yeah.
Okay. Yeah, DOME. Sure. Any other questions you have? It kind of speaks for itself. We're literally just getting started. We're starting looking into starting some farms, to get more liquidity in there. And what I tell people is...
There's already projects picking up DOME, by the way. There's already projects on PulseChain picking up DOME and creating farms with DOME. So,
nice.
That's very good. Congratulations also on that.
Thanks. And
you have any plans to expand to other networks other than X? Than Pulse, sorry.
You know what? I'm not the guy to ask that question. You'd have to ask my partner. He's got the roadmap better. There's more and more being added to the website. You can check it out anytime, domeshot.io.
Right.
And we have some great plans. We have some great people working with us, and we're bringing more people on board as we speak.
Very well, man. Congratulations on DOME. I'm sure it will be a very cool experience a very cool project to watch. I got it. So I'm shilling my bags, but you guys already know that I love to chill my bags. So X to the moon, DOME to the moon, Pulse X to the moon, Pulse to the moon, everything to the moon.
Absolutely. All right, guys. Thanks for having me on. I appreciate it. So
thanks for coming, Dave. It was a pleasure.
Good conversation. Hey, and the guy that's trying to figure out the Earth is flat, just check out the crash course videos. Just watch them with your significant other, whatever, family, by yourself. There's some great videos there. There's one that's called 21 Questions. That's a great one. It goes through a lot of the points and just gets you thinking. And so, again, don't believe anything I say.
No, sure. But if I get the app, there's stuff there, right?
Yeah.
Already.
Yeah, no, it just makes it easy. But you actually don't even need to get the app. It just start with the videos on the website. They're all free. You don't, sure. The app is just linking to stuff that you can't find. That you can't find. You don't need.
I'm gonna give them the app. So
you're gonna give them the app because you're gonna get $7. You're gonna get $7 worth of DOME.
I'm gonna arbitrage that motherfucker. Yes.
Yeah.
Nice one, Dave. Thanks a lot for coming, man. Yeah,
I appreciate it, man. And ignore the trolls because they friggin' love going after. They're everywhere, right?
It's proof that you're doing something.
What about plans for the future?
We have we're gonna have a store. There's gonna be conferences and all sorts of stuff that you can buy your tickets with DOME. There's gonna be all sorts of stuff, and then we're gonna have other people are gonna be able to put their products on our platform and then accept some DOME, all DOME, whatever they want. They'll be able to. We're gonna kind of make a marketplace so you don't ever have to off ramp your DOME. You can just use it to actually buy physical goods.
Cool.
Nice. Merc, I like that.
Yeah, but I mean, like, even for yourself, like anything.
My plan is to be a DOME multi-billionaire and never cash in a single DOME coin. I just want to be a billionaire on paper, and I'm not going to cash any of it in.
To impress all the ladies. Yeah. That's good. That's smart.
Yeah.
Smart.
Yeah. Here's the thing. You guys brought it up right at the beginning. This could be a rug pull. Sure, it could be. Matt and I would have to pull the rug out from everybody and literally lose our entire reputation. You can trust us or you cannot trust us. I say, if you don't trust us, don't buy any DOME. Whatever you do, don't buy any DOME.
Don't you think that crypto, it's, at least for me, the crypto, it's about not trusting anybody. That's why Bitcoin, it's so cool because you don't have to trust anybody, not even Satoshi, that doesn't exist anymore. And on DOME, we have to trust you.
Well, it's the same thing. Same thing with Hex. You got to trust Richard Hart. So again, we're going to start giving away our bags too. Like when the DOME supply runs out, we're going to start feeding our bags out too because we want as many people holding DOME as possible.
But in Bitcoin, you have to trust that Satoshi is not going to dump on you. He holds 1 million coins at least that we know. So it's the same level of trust.
Right.
There's no difference. Satoshi also owns 1 million coins. So. Who cares?
Here's the thing. If you have trust issues, do not buy any DOME. Okay? Do not sell your DOME today. Sell it today. Okay? Sell the free DOME that you got. Sell it today.
Sell it to me.
Sell it. Sell it.
He's going to buy all the DOME. Beware. Kiku is very, very powerful. He's going to buy all the DOME.
Yeah, man. Thanks so much, guys. Have a great day.
Thank you for coming, Dave. It was awesome. Thank you, buddy.
See ya. Bye-bye.
Bye-bye.